Okay, let's start. Paper 3. Online people, I hope you have your papers. Yeah. Guys, this year's experiment is going to be a pretty easy one. Good for you. But it also means what? Because the whole country knows what is coming out, right? It means that the thing that sets apart your grade is going to be your paper 1 and paper 2. Okay, so the whole country knows what is coming out, and if you don't do well, you're gonna be missing out. Usually, for paper 3, people are gonna get 12 and above. Yeah, try to aim for that. Try to aim for that. So today we're gonna go through all the things that you need to watch out for, especially the common errors. Like in the table, you all usually will forget your decimal place, you lose 1 mark. Not consistent, lose 1 mark. Forget unit, lose 1 mark, that kind of thing. Okay. We go through the general guidelines first before we will touch on the actual experiment later on. Let's start with from the top. Okay. Please read the question carefully. Whatever they ask you to investigate will be very clear. In the first 2 sentences itself, you will already know roughly what is the MV and RV. And even if you read already, you still don't know, go and take a look at the graph. Because normally the graphs, they will tell you RV is here, MV is here. Usually. Yeah, usually. It could be guided or unguided. Guided, you just follow the procedure exactly. Unguided, later I'll teach you how to write the procedures. Don't worry. And also, whenever you write your variables, make sure it's something that can be measured, especially for physics. I know for chemistry and bio, you can write things like type. You can write things like size, maybe. But we don't write all these words in physics because it's too general. Amount, you can say mass. Amount, you can say volume. You don't just say amount. Like, what is a big amount? What is a small amount? Very, very hard to imagine. Or what is a size? You can say length log, a long wire, a short wire, a thick wire, yeah, thickness, area. All this can measure one. Something that can be measured. I think chemistry can use type. I'm not sure. You ask your chemistry bio teachers. But physics, we don't write type. If I got different springs, I will write spring constant. Yeah, I got different types of wire, I will write the resistivity of the wire. Different metal that heats up differently, I will write specific heat capacity. Yeah. For physics, it's damn easy. The inference. Just remember this format. You'll be fine. Hypothesis, if they ask, also free mark. These two, they love to ask. But be careful, it is the responding that depends on the manipulated, not the other way around. So for example, it's the period of oscillation that depends on the length, not the length depend on the responding. Okay. Constant variable is usually something that can affect the RV, like for example, the period. Okay, let's see procedures how to write. If we are looking at a pendulum, yeah, then you have a certain length. The period, I hope you know, you need to count from the start, swing to the other side, and come back. And that is period. That's the time taken for one oscillation. Okay. And how to get full marks, 3 marks for physics? The first mark, you must go and write how you fix the MV. For example, you go and say, I want to use a length of, let's say, 20 cm. For example, you already get 1 mark. You write your sentence, yeah, adjust the length of the pendulum to 20 cm, L equals to 20. And then how to get your RV? You use a stopwatch. You record the time, you record the period, for example. Got another mark already, for example. Okay, later we'll go through the full procedures and then repeat the experiment with 4 other MV values. So for example, you go and say, other than using 20, I also want to use 30 cm, 40 cm, 50 cm, and 60 cm, for example. Okay, you get full mark. Like that. That is the 3 marks for these 3 steps. That means in total, please make sure you have 5 readings. Minimum 5. I think a lot of you normally will lose mark because of the decimal place. So let's also take a look at how to decide how many decimal place. What is too little and what is too much, too many. decimal place must be consistent for each respective column. Guys, is column go down or column go to the side now? What is a column? Down is a column. Sideways is called a row. Every column must be consistent. But column number one, maybe all one decimal. But column number two, you can do two decimal, no problem. Column number three, you want to do three decimal, no problem. Like respective column, this all column one decimal. Like in this table, if it's one decimal place, then all one. If it's two, then all two. If it's three, then all three, like this. Okay, don't sum one, sum two, one, two, three, like that, the one. Straight away you lose a mark if you never write consistent decimal place. And you please follow the smallest reading in your apparatus. For example, if your ruler can read up to one decimal, then you follow lah one. 8.9, 12.5, 15.0. If your ruler can read two, then you follow lah two. 9.85, for example, 12.50, 15.00, please write the 0. Okay. And then you know how sometimes, right? What if the value is in between, let's say 0 is here, 1 is here. What if the value is here, in between? Between 0.4 and 0.5. Because normally your ruler, maybe you will say, teacher, my ruler can only read one decimal place, right? 0.1, 0.2. Everyone is just one decimal anymore. 0.1, 0.2, 0.3. Can I put 0.35? Why not? Can. 0.35. So if you decided that you are going to take the point, the 35 in between, then for everything in that column, you're going to put all two decimal. 5 is okay. If you take in the middle, can. You don't tell me, teacher, my eyes can read 0.33, that kind. Don't lah. Okay. So either in the middle, or if you want to save the trouble, teacher, my eyes saw like somewhere in the middle, but can I just save the trouble and write 0.4? Can also. Who knows? Nobody knows. Yeah? Nobody knows. So this is up to you. If you decided one, then all one. If your ruler, if you really want to stick to 3.5, then everybody just two decimal, no issues. Okay, so that is following your apparatus skill. However, for calculated values, that means anything not directly from the apparatus, decimal place can be higher. Like for example, your stopwatch recorded 18.3 for 20 oscillations. Can you count for me one oscillation is how much? 20 oscillation is 18.3. One oscillation is how much? Can get 0.915. Yeah. Can I write all three decimals? No problem. Can I round off to 0.92? Also no problem. Two decimal is fine. Can I do 0.9? Too little. 0.9 is too little, I feel. So 0.92 is okay. 0.915 is also okay. Can you do object distance is u? I want to do 1 over u. Can you figure out the 1 over u value? 1 over 14.5. 0.068. I put 4 lah, very long. 1 over u meaning the unit will be per cm already. Cm -1. Okay, must also know what is your unit now. And if you don't want this, you can round off to 3 decimal. This is 1, 2, 3, 4, 5, 5 decimal. 4 decimal 0.0690. Also no problem. 0.069. Also no problem. Okay. Usually this experiment, the values are quite small. Lastly, if I have an angle of 33 degrees, and then they ask you to plot a graph of sine R. Okay, let's do sine 33 degrees. Like this can. 5, 4, 5 also can. 5, 4 also can. Do you think sine R got unit? The sine R have any unit? No unit. Sine is actually just a ratio, no? Usually you do so ka tua, right? So is what? O over H. So you're just doing ratio of opposite side over hypotenuse actually. So it's just a ratio. It doesn't have any unit. Yeah. Later we see how many decimal place we should put for our pendulum experiment. Then your tables can have more than 2 columns. Some questions have the table prepared for you. Sometimes you have to draw the whole table yourself. Your table can look something like this. Yeah. Important thing is make sure must have the unit lah. So I have a little checklist for you. Usually the mark schemes will have all these things. You can read through later, but the important thing that usually people miss out is just the unit. Because number you will go and write lah, right? And then the values, values as in, you know that it should follow a certain trend. Like for example, I know longer pendulum should be longer time lah. So just try to make sure that it is an increasing trend that will do. Okay? As long as it's nothing ridiculous, then it's fine. Yeah. And also, lastly, is the decimals lah. This 3. Because the rest you guys will be fine on. You will put the physical quantity there. On top, you will say mass. You can write in words. You can write in symbol also can. Or just write M. Length, can I put L or not? Can. You can just put L. Teacher, I very paranoid in the table. I want to write length of pendulum, L, and then cm like that. Can or not? Can. Up to you. Or can I just write L/cm? Also can. Doesn't matter. You want to write the word? You want to just write the symbol? Also can. Does it have to be SI unit in the table? No. It doesn't need to be SI unit. Don't have to be SI unit. Nah. Meaning length can be cm. If you are using cm for the whole experiment, you follow cm only, no problem. So length can be, for example, cm, can be mm, can be meter. For example, or you just follow your experiment. Don't have to be SI. Time most likely seconds lah. Mass can be in grams. Don't have to be kg. Decimal place consistent. Follow instrument. Make sure you round off carefully. Yeah. But just remember your unit and decimals lah. These 2. Usually people lose marks there. You see, got a lot of marks, right? So maybe if you get like 8 corrects, then they will give you maybe 5 marks, for example. Or if you get 6 or 7 corrects, then they will give you 4 marks like that. So that's how they mark. They'll tick, 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 and then they count how many ticks. The table can be 3 marks, up to 5 marks. Sometimes even 6 marks. It depends on the year. Okay, the graph should minimum pass through 1 to 2 points. Minimum 1 point also can. 3 points also can. 2 points also can. And if any points never pass through, you should balance above or below the line. And then don't forget the unit. Don't forget the unit. Graph must be more than half a graph paper. So if really you cannot fit into half the graph paper, it can be portrait, no problem. Can be landscape also can. Meaning your graph paper, you can, it's like this, right? You can also turn it around and draw the graph. Okay, unless they already draw the axis for you, then okay lah, too bad. But then if they just give you a graph paper, you can use the graph paper like this. Landscape, you can use portrait also again, no problem. As long as the graph is as big as possible. And you choose a good scale lah. Don't choose weird scales. Okay, got a long list here. Axis lah. Make sure you label properly. Your scale. You label lah. If on top is t squared, always make sure unit. That's your axis. Scale. Make sure you do properly consistent. Size of the graph. And then don't forget to extend your graph. That means you will very likely only get some points that is floating very high like this. You don't just draw like this. Okay, maybe bio, I think bio, you're not supposed to extend, right? Correct me if I'm wrong. But you ask your bio teacher, I'm not sure. But for physics, you must extend. Okay, for physics, you must go and extend your graph, go until it touch the axis. Must touch the axis, If you don't extend to touch your x or y axis, it will affect your relationship mark later. Your relationship mark will be 0 if you never extend, even if your relationship is correct. Okay, axis, the scale, the size, extend. Okay, then based on your graph, state the relationship. Question already say based on your graph. I want to ask you something. What if you really did your experiment and for whatever reason your graph is just like that? No matter what you did, you try and try and try and it's still this. The t-squared and L graph. How? Do you think you can still get 15 out of 15? You can. Why not? You can still get 15 out of 15, no problem. But then your relationship, you must go and say t-squared increases linearly with L. This is a paper 3 question. It's not paper 2. We are testing you on your experimental skills. Your result is like that, then like that. Oh, what can we do? Yeah. So your graph is like that. As long as it's an increasing trend, you drew a straight line, and for whatever reason, your line just can never pass through 0. Your best fit line never pass through 0. Let it be 15. You still can get full marks. Yeah. But then you follow your relationship, increase linearly. But you try to get this if can. It will make life a bit easier for you. Most likely it's going to be this. Okay, it should pass through 0. Because when the length is 0, there should not be any period. Length of pendulum 0, there should not be any period. So guys, remember, you can adjust your values one. Okay, I shouldn't say that. But you can. Who knows? Nobody knows. And also spend time on finishing your paper. 40 marks is a short time. 40 marks is a really short time will fly past. If no time to finish experiment, forget it. You did a few already. Put in some, and then you draw. Finish your paper. The paper is the important part. The examiner marks your paper. Not they don't know what you did for the experiment. Spend your time on the paper. Okay, draw graph need time one. Answer questions need time one. Experiment if really cannot finish, you at least you did a few. You roughly know the values. You put, and then you draw. Paper must complete. The marks is from the paper, not from your experiments, and they wouldn't know. Okay, and then the gradient. Must draw triangle. If they ask you to do gradient, later I show you what does it mean by this triangle. And the triangle must be big enough. So normally I like to take 2 points, and I will draw this right angle triangle, dot, 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 dot. Usually the triangle will get 1 mark. And I will use 2 points that are on the line that is easy to read. You watch what I say here. Don't use points that you plot. Don't use points that you plot unless they are perfectly on the line. Okay? So they could be, you could have some points higher, lower. Let's say like that. But you see the 2 purple color points, it's not any of these red color points, and it doesn't matter. I'm going to choose 2 points for the gradient, and I'm not taking any of the red color points that I plot. I go and choose this point called 0, 0, and I go and choose this point that is whatever this is called like your x2 and your y2, right? This is your x1, y1. It doesn't have to be a point that you got, as long as it's on the line. It's even better if you don't take all these points, because all these points usually not very nice, quite ugly, got a lot of decimals. I want to find gradient of the line. I don't want to find the gradient of all the points. I'm not interested in that. I want the line. Okay, so remember that. And then you do your gradient. People usually will forget something. In maths, every time you find gradient, you normally don't write a unit, if you notice, because they are just coordinates. But if I got this graph, the unit will be s squared over cm. So later gradient will become something s squared per cm. Okay, something s squared. So just take y over x lah. Yeah, y over x. per cm. If the values recorded in the table is 3 decimal place, can the graph be 2 decimal place? The decimal place for your graph, you just follow your table, I feel. Okay, if you do all 2 decimal, then your graph also you do 2 decimal. If it's 3, then you follow your graph all 3 decimals. Like what you put here lah. My length all I do 1 decimal. So maybe 10.0 cm, 20.0. I just follow my table. Follow your table. Okay, we'll go through this again later when we go through the example question. Operational definition. Normally you try to relate to RV, what you got, what you see, right? And also measuring instrument. So actually this experiment, very difficult to ask operational definition. And actually operational definition not supposed to be asked in physics. It's a chemistry and bio question actually. It's not supposed to even come out in physics, but some state papers keep asking it. And if really asked, you just try to write something. Later I got prepare one version for you. Like inertia, normally we will say is the period of oscillation. The liquid pressure, we will say is the height difference in the manometer or in the U-tube. Yeah, the liquid pressure, the height difference, things like that. Last year was talking about buoyant force. Buoyant force, you normally will measure the volume of water that displays using a measuring cylinder. Yeah, is it using a stopwatch, using a meter rule, things like that. You can read through lah. Precaution, we always will write this. Ensure eyes are perpendicular to the scale reading of, you write lor, your meter rule or your stopwatch also can, to avoid parallax error. Okay, lastly, last 2 marks, normally they like to ask prediction. Right? They'll ask, if I change the pendulum to a greater mass, for example, what happens to the period? Or what happens to the gradient of the graph? And then they can ask you to explain. You just normally will say increase, decrease, unchanged. Okay, why must it be this 3? Because it is, the whole paper 3 is something that you can quantify one, something that can be measured for sure. So it will either increase, decrease, or just won't change. Only these 3 answers lah. Normally lah, normally. Okay. We take a look at this example question. I have to give credits to some students who sent me some stuff. So I took lah from whatever, because you all got a lot of antenna and a lot of resources, more resources than I do sometimes. And so I just get from whoever was sent to me, and I compiled and I made up this whole question, and I changed some stuff, added whatever I can think of. Hopefully it helps lah. Okay, so we got a figure that shows some bird nests, similar mass hung on a wooden beam, strings of different length. We want to observe period of oscillation. Straight away, you will see some important info. But bird got similar mass. Yeah. Based on the information, state one suitable hypothesis. Longer strings, greater period of oscillation, greater. The greater the length of the strings, longer also can. Or increase also can. The greater the period of oscillation. You want to write longer, you want to say increase, and also, can you fill up the inference yourself? Use the word depend on. The period of oscillation depends on the length of the strings. Okay, so they can ask something like that. They can give something not related to the experiment yet, just like a warm-up question, and then only we do the usually unguided will be like this. They'll give a situation similar to your experiment, and then they will ask you to do something unguided. Okay, if guided, you follow exactly the procedures. When should we use greater, greater, or increase, increase? For hypothesis, both also can. Huh? For hypothesis, both also can. Part C, based on figure 2, using apparatus such as pendulum bob, meter rule, stopwatch, retort stand, the strings, G-clamp. Okay. Guys, is the clamp important now? No, it's not important. As long as your retort stand never shake, then can it? Okay, as long as you swing your pendulum, your retort stand never move, then can it? So in the first 5 minutes of checking, right, what do you need to check? Most important thing, you check and see whether your retort stand keep on shaking or not, this stick. If this stick keep on shaking, you faster raise your hand and ask them to change if can. You find something that is stable, or else very very hard lah. You swing and then the retort stand also swing and then the pendulum also swing, yeah, and then your reading also a bit chachak. So we try lah if can lah. I know some schools don't have very good retort stands, but the clamp is just to make sure it doesn't move lah. So as long as it's stable, then it's fine. And then we will put a plywood normally to the plywood is usually got two pieces. They might not even give you a plywood to hold onto the strings so that you start measuring from the bottom. You start measuring from the bottom, from here all the way until here. This is how you measure. Yeah. So you can measure whatever 20, 30 cm. Also another thing, when you bring your pendulum up and release, you don't release too high. You release a small angle will do. If you release too high, it will affect your reading one. So you just release a little bit, just take a small angle and then just let go. Don't have to be, don't do high, don't want. Just a little bit, let go, and then start counting. Okay, go and come back is one. Go and come back is one oscillation. So you count 10 or 20, depending on the procedure. Okay. Your school teacher told you, someone said, that they actually already set up everything for you. She said it's weird because normally they do that. Oh, I don't know. There you see, some school. This is a student from Klang, by the way. Some school say the teachers already set up everything for them, or maybe they already did that for you. I don't know. So year to year they can change on lah. They can change, and if they did for you, good luck. You just do your experiment only. Okay. Using the apparatus provided, plan an experiment to investigate the hypothesis stated. Write procedures, including a method to control the manipulated variable, a method of measuring the responding variable. Carry out the experiment to investigate how the pendulum string length and the period of oscillations are, find the relationship between these two things. Okay, this one, the question says specifically, use length of 40, 60, 80, 100, 120. They might not give you this. Let's say if it's unguided, they can totally let you decide on your own. So you can decide yourself. Maybe you do 20, 30, 40, 50. 20, 30, 40, 50, 60. Okay, 5. 5. 20, 30, 40, 50, up to you. Right? Some people say, teacher, my meter ruler, one meter only, so I cannot measure. You do 1 meter plus 20 cm. Yeah? Okay. And then number of oscillations can be 10, can be 15, can be 20. You follow your procedure if they give you. If they never give you, you can decide. Okay, but you read carefully lah. It doesn't have to be a 10. Your first mark will be awarded here. Why? Because this is the step where you fix your MV. You will notice something. We would like to write the symbol. Adjust the length of the pendulum, L equals 40.0 cm. Move the pendulum bob at an angle less than 10 degrees and release it. Move a small angle and then release it. Number 3, number 4, you get another mark. Because you fix your RV. Measure and record the time. Again, you see, we will write the symbol. The time is called T, let's say, for 10 complete oscillation. Don't memorize, follow the question. If they say 20, you do 20. 30, then 30. 15, then 15. Using a stopwatch. Calculate the period of oscillation, big letter T. You take T divided by 10. And then find the value of T squared. This is for the graph later. Okay. Last one. Repeat steps 1 to 4 with a length of pendulum. Do you see we use the symbol again? L equals to, you write exactly like this, L equals 60.0, 80.0, 100, 120.0 CI. Or can be other values. Follow your questioner or decide yourself if not given. Okay, maybe you don't want to do so long. Just do shorter, it's fine. There is also another version. They might ask you to find T1, T2, and then find the average. That means conduct experiment 2 times. Okay, if they do ask you to conduct experiment twice to find the average value, then you can add your one more line somewhere here. So after finding 10 complete oscillation, you just add a repeat experiment to get T2, let's say. And then maybe you will have one more step. Find the average time, which is T1 plus T2 over 2 like this. And then the rest of the steps are the same. You still want to calculate the period of oscillation the same way, yeah, and then find the T squared the same way. This is if asked to do experiment twice. Your school teachers say protractor have to bring on their own. I don't think so. You're allowed to bring in a protractor. You can, okay, you can bring in a protractor. You don't need a protractor. Just take out a little bit and release. Don't need to measure, it's fine. Don't need to be so accurate. We measure the angle with a protractor. You can mention the protractor, but the protractor part is not that important. Just as long as it's not too high. Don't want so high. Just a little bit and let go. You don't actually have to measure it, it's fine. Do you have to add record in the table? You don't need to. You want to, can. Guys, this is the minimum. You want to write more, it's fine one. Okay, so my suggestion is when you all have time, this weekend or whatever, you cover the procedures and try and see whether you can write the whole thing yourself or not. If okay, then no problem already lah, right? And then also be flexible. You must know if I ask you to change some length or change the number of oscillations, you are prepared for that. If 20, you have to divide by 20 then. Okay, can? Or let's say the question didn't ask you to do T squared, then you can cut off this part lah. Don't need T squared lah, for example. Okay, can you read all the values for the stopwatch? This is 12.6. Every one small line is 0.2. I get 12.6. This is 11. This is 12. Will you ever have a 2 decimal situation? Can that be 2 decimal? No, because one small line is, the next one is what, 12.2. So even if you take in the middle is 12.1, there's no way it would be like 12.15 like that. No. Is either, so it's definitely 1 decimal. My one is right here, 12.6. You divide by 10, you get 1.26. Can you all find t squared? Okay, we are now going to make a decision. How many decimals are we deciding for t squared? You want 3 can, but then, okay, so I squared, I got 1.5876. If 3, later this number will be quite hard to plot. Is 2 okay or not? 2 actually is also okay. Okay, you want 3 also okay. Is there a limit? No, there's no limit. You know, last year asked to find buoyant force, you can put 5 decimals, also can. You want to put 6 also can. Then all 6 are 6 all the way. Okay, just that if they ask you to plot a graph, then a bit hard for you to plot lah. You have to manually round off yourself. Okay, either one is okay. You faster read the rest and we complete this. Yeah, I'll just do 2 decimals for t squared. You want 3 also can. 4 also can. All the 0, please make sure you add 20.0, 2.00 squared already become 4.00 or 000 if you do 3 decimals. And then next page still got one more stopwatch. This kind of stopwatch is analog stopwatch, right? It's called a mechanical stopwatch. Have you all used a digital stopwatch before? Your school got digital stopwatch? I don't know, my time last time don't have, no money. But now these days, maybe you all got digital stopwatch, I don't know. What if they give you a digital stopwatch? Then even easier, you just start and stop. Okay, then they'll give you the number. Usually will have a bit more decimals then. You just write only lah, just follow only. Okay, if your stopwatch got 2 decimals, you just follow, you write 2 decimals. And then your t-squared, you just can follow two decimals again. You want more decimal is fine. Okay, you want more decimals or maintain the same decimal is fine. Yeah, but can be digital also. And then got students also ask, teacher, can you suddenly change the experiment to become something else? I think it's a bit hard because the whole country needs to prepare for this. Every single student needs to prepare for this experiment very early on. So like 2-3 weeks, actually 1 month before paper 3, your teacher already got the list of apparatus. Your teacher don't have the question, but your teachers will already have the list of apparatus. Need to make sure every school got all the apparatus. Not enough, they need to buy. And then government will give them money to buy. Right? That's why now you all got a lot of apparatus. Last time really don't have all this paper 3 stuff, so we don't really have I never seen a digital stopwatch in school before. It was always this, and then the whole school only maybe got 2 of this stopwatch. Now every student got one. Last one is this 20.0, 2.20. When we square it, 4.84. Okay. Based on the experiment conducted, state the manipulated variable. Length of pendulum. I like to put the symbol, but it's optional. Okay, you don't want to write cursive L like that. You just want to write L like this, also okay. Right? But I like to write the symbol just to make things very clear. Yeah, but this is optional lah. But I like to put it down. And then period of oscillation. Responding variable. I like to put down T like this. Okay. The constant variable is mass of pendulum. Sorry, one more word. Mass of pendulum bob. Who's Bob? Bob is the ball, huh? The ball is called the ball. The ball. The ball is called the bob. Yeah. Mass of pendulum bob. You want to write M here, can, right? But it doesn't really matter because I don't really care about this bob. I don't really care about the mass. Okay, the mass actually doesn't affect your results. You can use a 1 kg bob and a 5 kg bob. It's going to give you the same answers. Actually. But I'm writing mass because I'm avoiding to write the word type of pendulum. I'm avoiding to write the word type of pendulum. And then I know some of you very paranoid one. You will say, teacher, I go and write period of oscillation of pendulum, can or not? Right lah, it's fine. As long as you have the word length, you get marked. You have the word period, you get marked. You have the word mass, you can get marked already, actually. Yeah. Angle of release. You are right. It's supposed to be correct. I suggest you to write mass though. You know why? This is the textbook answer. So it's the one that is confirmed right. Okay, so it's not wrong, but I don't want to take chances, lor. I don't want to take any chance. Okay, I don't want to take any chance. This is confirmed correct. It's the textbook version. You want the fan, is it? Okay. Guys, can we do our table? You all can do in a pencil form. The LT squared, LTT and T squared you put on top, huh? Guys, don't OCD lah. Table ugly, never mind. As long as values all there can already. Yeah. You got no time to OCD or don't need 5 cm. Just draw only lah. Just draw. Yeah. Don't need to write the words. It's fine. L. This is cm. You want to write L bracket cm also okay. Slash also okay. T is in seconds. Big T also in seconds. T squared. Second squared. And then can you transfer all your values here? Okay, so I got 40, 60. The table you can draw in pencil, but then you write the values in pen. Okay, let's transfer all the values. 12.6, 15.4. 2.54, 2.37. Okay, but guys, a good student would also read through a little bit of other experiment lah, right? I know most likely this one, but then maybe you read through a little bit of plasticine also, the inertia on the hacksaw blade, that one. I just read through a little bit and know what is going on, know what is the difference. Yeah, a good student would read through more. Yeah. Are you a good student? Okay, 2.00, 4.00, and then lastly 22.0, 2.20, 4.84. Okay, I do one, then all one decimal, two, then all two. Yeah, that's what I mean. And you're gonna get full marks like this. this top row, symbol must have, unit must have. Okay, and then everybody here, you get correct, you get another mark. And then a consistent decimal, you also get mark. Okay, so if you want all three decimal, can go ahead. All three is fine. For the values you calculated, you can write more, but the apparatus one, you follow your apparatus. This one follow apparatus. Okay, anyone want to write length or pendulum? You can, but it's optional. It's not needed. You can just write the symbol will do. No problem. Unless you are very free lah, and you got plenty of time, then you write lor. But don't need, don't need. Unless you don't know what is the symbol called, then you write the words. Let's say you don't know what is, I don't know, but usually got symbol one. And then plot the graph. The graph I already did for you. Already got the graph behind there. This one, okay? So according to this one, it should pass through 0. Two pages later, you go and check and see. The relationship is directly proportional. You just write t squared. Is directly proportional to L. Please make sure you write this, the t squared and the L. Don't just write directly proportional. Okay, don't just write directly proportional. Write this and this. Then can you calculate the gradient? Calculate gradient. Also show on the graph how you get the gradient. Sorry guys, can you add a short phrase here? Can you write in SI unit? If they never say SI unit, it's fine. You don't need to write SI unit, it's okay. But because I need the value for part I later, part H, part I is related. So later you go and find the gradient in SI unit. Okay, we're gonna do gradient. They call gradient as K, just follow only. They call M, you also follow, it's fine. Let's go to our graph, show on the graph how to do. Okay. You know what is the point I like? 0, 0. That's the best one. Use lah. This point so nice, 0, 0. Use. I think this point also very nice. So happen to be perfectly on the line. Yeah. 100, comma 4. Sorry. Very perfect. Okay. This is how I like to do it. You can follow, which is to write down the coordinates. In MS also, you all can do like that when you find gradient of linear law graphs. And then you can go and do your dotted lines, draw the right angle triangle. You can do the whole thing in pencil. Label the 90-degree. The triangle will get 1 mark if they ask you to show on the graph. Question, can I draw a triangle that is like this, so small? Cannot. We don't want small triangles. This one too small already. I don't want this one. Size. Yeah, size matters. You just want me to say that? Yes, size matters. Okay, so why the triangle cannot be too small? Okay, because if the triangle is very small, you use points that are very close, you go and draw the graph, and then you happily think that, okay, I get the gradient for this line. But actually, if you use a further point, maybe the point is supposed to be here. And I want to show you, when you look at the 2 points that are really, really close, you cannot really see the difference between the purple and the green one. But maybe the correct one is the purple one, but you went and find the gradient of the green one. You get what I mean? So very close will give you error one. I want big triangle, will be more accurate. Draw a big one. It's not locked, it's just stuck. Unlock it. Pull it. It needs a few try. Cannot. Right, the door spoiled. Okay. Yeah. Minimum have 8 cm, meaning 4 box. 1, 2, 3, 4 at least. Or you can do 4 box vertically. 1, 2, 3, 4 also can. Minimum lah. Right? Bigger is better. And also, you want to extend this part. Oops, sorry. You want to extend this part is okay, but down there you must extend. You must extend, go to the bottom and try to touch 0. Bring your 30 cm ruler if you have. That'll be best. Yeah. Or you can use the meter ruler also can. The meter rule that is provided also can. So K is equals to Y2 is what? I forgot already. 4. Y1 is 0. 100 minus 0. Careful. Y-axis is S squared. Right now, X-axis is cm. Okay. But if I want SI unit, then you change lah for S squared. Down here, you can write as 1 meter. Okay. 100 cm is 1 meter. So you get 4S squared per meter. The value that I got is very nice. Yeah. But you can have decimals is fine. This is SI unit. If the question asks. Okay. If not SI unit, then it would be this. Oops, sorry. It'll be 4 over 100, 0.04 S squared per cm. Also okay if the question never asks for SI unit. You see what the question wants? Okay. By right, both also okay. Okay, you get 3 marks already. 1 mark, 1 mark for here, and then also you draw the triangle, you get 1 mark. Can you do part 1? Sorry, part I. Is there a range of data recorded? Because during trials, there is a range, someone asked. Actually, SPM don't have a range. Or the range is just very, very big. Yeah. So, but you don't tembak values lah. Huh? You don't tembak values. You just do your experiment. And you will know rough. This experiment very hard to go wrong lah. Let's just put it this way. Yeah, let's just put it this way. So don't worry about that. Don't worry about it. Don't worry about the values. The graph scale, don't use 0.3. Don't use 6, don't use 9. Scale should be numbers that is either 1, 2, 5, 10 if possible. The scales should be any numbers that is 1, 2, 5, 10 if possible, like 0 0.1, 0 0.01, 0 0.2, 0 0.5, 10, 20, 30, those kind of values if can. Try not to use weird scales. 3 we don't like. 3, 6, 9 we don't like. Yeah? They give you this. This is not in syllabus, but I think you all should remember this because it will help you to know what will affect the period for a pendulum. Find the value of gravitational acceleration g using the gradient value. What's the gradient representing? T squared over L, right? Y over X. Okay, so you take the formula and you go and rearrange T squared divide by L. You take this L and then you divide, come down here. Then you will just get 4 pi squared over G. And then this t squared over L, just now you found out the value is 4. So you substitute as 4. That's the gradient. Okay, then you find out the G for me, please. The pi, just use a calculator pi. You want 3.142 also can, but just calculator pi will do. How to find G? I multiply the G go up, I divide the 4 come down. G is equals to 4 pi squared over 4. G equals to, the 4 and 4 cancel out. You see whether can get 9.870 or not. Your calculated values, you just do like paper 2, that kind. Just 3 decimals, no problem. You want more also can. Meter. If you use the non-SI unit, then you're going to get cm per second. It's not wrong. It's not wrong. Yes, it's not wrong. So if you use the non-SI unit, then it would be 4 over 0.04. You get 986.960. Both are okay, but this is the SI unit version. Because just now we use SI unit. So now we will also get SI unit. Okay. Okay, guys, we take a quick break before we continue. Short one. Those haven't gotten your snacks yet, you can take. Yeah, short break. We'll come back in a bit. Left a bit left. Okay. Jay, based on the graph drawn, predict the period of oscillation for L equals to 20. Okay. Show on the graph. This is the reason why this can go up to 3 marks, just because of the show on the graph part. Yeah. So you go to your graph, you go and find where's L equals to 20, and then you draw dot 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 dot, dot, you get a mark already. If they ask you to show lah, even if they don't, you should show. So go to your graph, you find 20, then you can dot dot dot. What's the value? 0.1. Okay, you see carefully, is it 7? Zero 0.8, right? Okay, now every 2 box is 0.1, 0.6, 0.7, 0.8, 0.9, 1.0. Okay, it is 0.8. If you got somewhere in the middle, you just find the 2 values and then you divide by 2 if you don't really know how to read. Yeah. Okay, if you really don't know how to read, you take this 0.05, you divide by 10. That means one small box is what? 0.05. Yeah. Then you count how many boxes and then you just times. Just move 1 decimal place, you will know 1 box is how much. Okay. 0.8. Is it the t value already? No, this is t squared. So you get a mark for finding the t squared, and then don't forget. That's why look at your y-axis. That one is t squared, your one is t. You square root your answer lor. And whatever calculated values, you can just do 3 decimals like normal, like in paper 2. And this would be in seconds. Make sure you have your unit. So that's 3 marks. Show the dotted line, find the t squared, find the t. But K, other than the length of pendulum, state another physical quantity that can affect the period of oscillation of pendulum. That's why I say it's good to know your formula for pendulum, 4 pi squared L over G. Yeah, since you're already preparing for this experiment, you prepare fully lah. Yeah, I know not in the syllabus, but it's good to know that L affects the answer, G also affects the answer, not mass. Gravitational acceleration. What happens to the gradient of the graph if a longer string is used? Will it change or not? What do you think? Increase, decrease, unchanged? It is actually unchanged. It is actually unchanged. Why? Because do you recall just now the gradient? Okay, I know why some of you might think increase because t squared over L, right, equals to 4 pi squared over g. This is the gradient. The gradient actually represents this, which is a constant. 4 pi squared will never change. It's a fixed number. Pi is just 3.142. You square it, it's still fixed. You divide by g value, it's still fixed also. So using a longer string is still going to give you the same, remains unchanged, the same gradient. What happens to the period and the gradient if a greater mass of pendulum bob is used? Also unchanged. How to see? Because the formula don't have mass. Yeah, and then you'll be thinking, but teacher, why are you going to write constant variable is mass of pendulum? It's because I'm trying, like I said, we're trying to avoid the word type of pendulum. Type is too general. Instead of saying type, I say mass, but actually the mass should not affect a simple pendulum. Yeah, it's the G value that affects it. So again, remains unchanged. All in all, just remember the formula, what will change? Only L and G. Only L and G can affect, everything else will not affect. So that's why if I ask you a K-Bar one where I say, what happens if you conduct the experiment in the moon or in Mars? Moon and Mars, the similarity is both also lower gravity than Earth. Okay, the gravity is lower. Okay, let me pull out the formula one more time. T squared equals to 4 pi squared L over G. Lower gravity means greater period. P increases. I joined two questions in one because it's the same category. Gradient also increases. Explain why. You just say because the moon or Mars both also have smaller gravitational acceleration. And then part O, they can ask precaution. Precaution is popular. Ensure eyes are, you don't have to follow exactly the same sentence, but as long as you write nicely, then it's fine already. Maybe I should say meter ruler instead of ruler to avoid parallax error. And then if you use those kind of stopwatch, analog stopwatch, then you can also say stopwatch. Eyes are perpendicular to stopwatch when measuring to avoid parallax error. Okay, but you can write the first one. First, confirm you will use ruler. Guys, digital stopwatch will have parallax error or not? Digital stopwatch, you read from here, the number is still the same. The needle, there's no needle. Digital stopwatch got no needle. Okay? Okay. Is the British name of a meter ruler? Okay, but B, catch the, okay. What if suddenly come out something K-bar? The whole world expect T squared graph, but then suddenly they ask you to draw a T against L graph. Just be prepared for it. This is just a sketch. So I just want you to know at least the shape shouldn't be a straight line. P slash S against L slash CM. It should still start with 0. It should still pass through 0. but the graph is going to be this way. Sharp and then flat. At first quite sharp and then it flattens out. And the relationship is just T increases. You don't go and write linearly, T increases with L. Okay, T increases with L. You might be wondering, teacher, why must be this shape? Can it be like this or not? No, it's not going to be this shape. It's going to be like that because the relationship is like this kind. That's the formula. So when you rearrange, you are going to get, if you move the square, go over there. Square root of 4 is 2. Square root of pi squared is pi. Square root of L is like this. Square root of G is square root like that. Okay, so you get a relationship that is T and also square root graph. A square root graph look like this. A square graph would look like a smiley face. But square root is the opposite. Okay. Also, one more thing that I want to warn you, if you go and plot this graph, you are going to get something like this. Maybe. Okay. Please make sure you own self go and extend this part, no? Okay, you own self go and extend. Maybe your graph is maybe just that part. Then you just draw down yourself. If you don't see that part, actually it looks very weird. The graph will just be floating like this. Yeah. Okay. State operational definition for length of pendulum, very unlikely. You just, there's not much that we can say. Length of pendulum is measured by meter ruler only. You want to add in cm can. Yeah. That's why very weird. I don't think so they will ask this, but we just be prepared. State the operational definition of period of oscillation. The time taken for 10 complete oscillations measured with a stopwatch. If your one is 20, then you write 20 lah. 15, then 15. And then divided by 10 complete oscillations. Take the time for 10, measure with a stopwatch, then divide by 10. That is the period. That's what you did. Okay. Part S, why is the time for 10 complete oscillations taken in this experiment? Why 10? Why not 20? Why not 1? Reduce human error. You just write anything that has the word more accurate. So that it is more accurate, I think you get marked already. Reduce human error also you can elaborate. Because when you start or stop, you might start or stop too fast or too slow. That's human error. The reading for the period of oscillation is more accurate if you take 10 and then you divide by 10. We reduce the error at the starting and the end. Okay. Next one, why is the value of G obtained different from the theoretical value of 9.81? You go and say, because got energy loss due to air resistance. That's called damping. Why is the G value different from 9.81? Got energy loss due to air resistance. Or you want to say human error also can. Yeah, but I can say energy loss. Next one, state one assumption. There's no energy loss in the system. That's your assumption. Now we assume no energy loss. Last part, consider another experiment that uses spring system. Okay, with a period of oscillation of T. Based on the formula of this one, state two physical quantity that can affect T. Okay, for spring it's like this. Slightly different. Instead of L over G, we write M over K. The symbols used in the formula are commonly used in SPM. Do we know what is M? Mass. What gradient? Mass of the load. You hang a spring, different load will oscillate differently, right or not? Mass of load. That's M. K is what? Spring constant. I got a question to ask you all. This is a spring system for spring only. Don't mix up spring and pendulum. Your one is mainly on pendulum, but I just put this one extra because it's in the same category. Spring has a spring formula. Pendulum has a own pendulum formula, just so you know. My question to you is, will the length of spring affect period of oscillation of spring? Will length of spring affect period of oscillation of spring? Why you say yes? Very good. Because it affects the spring constant. Yeah. So don't say, teacher, here got no length. And so length does not affect. We learn in Form 5, there's a list of things that can affect spring constant right now. The length of the spring, the thickness of the wire, the diameter of the spring, the circle, how big the circle is, diameter of the spring, even the material of the spring, whether I use steel, whether I use copper, also it affects the constant. Arrangement also, parallel series also affects the K. Yeah, so a lot of things actually affects the K. Yeah. Okay. I think we're done. That's all I can think of. Yeah, it's not a difficult experiment. So don't I'm over preparing you all really. And plan your time wisely. Lah. Okay, Ken, I think you'll be fine. Yeah. Focus on finishing the paper. If really no time, dish the experiment. Just do it. Just do it. And quickly double check decimal unit for your graph for your table. Very easy to lose marks there. Okay. That's for paper 3.